are going to be called, up here it says arithmetic. Let me make that a little better. Arithmetic Sequences by Brett Herron. No, I don't know why it has my name there. I just, when I printed it, I guess. But anyway, arithmetic just means adding or subtracting the same number every time. So the sequences that we'll be looking at are going to add or subtract the same number every time. Next week, we'll do 12.3, and the sequences will be called geometric, and they will multiply or divide the same number every time. Those will be a little more advanced. So, all right, so now we're getting specific. So we did the general intro, 12.1, now specifically arithmetic. Everything in this section are arithmetic sequences, adding the same number every time. So here's a formula. Those curly brackets just mean the collection, right? Curly brackets, it just means it's like we're a collection of people, right? And there's a collection n plus 1, right? Collection. All right. Anyway, collection of numbers. All right, that probably totally distracted you now. Sorry. So we have that n plus 14. So now what we're gonna do is the same thing we were doing with the sigma notation. You're gonna plug in 1, plug in 2, plug in 3, crank out some numbers. That's what they want. They're saying S sub 1. S is just the name they gave the sequence. So they want S sub 1. So they're just saying plug in 1. What do you get? So if you plug in 1, you get 1 plus 14.
15.
So 15.
16, 17.
Exactly. And then now plug in. I'll come back to that D, by the way. Let's hold off on that. We'll come back to the D. Plug in the 2. 2 plus 14. 16. See what I'm doing? I'm just plugging in 1 and then 2 for the n. Just plugging into the n slot. Now plug in 3. 3 plus 14? 17.
What does D equal 1?
Yeah. Plug in 4. So 4 plus 14. 18 is the fourth term. Good so far? Got the first 4 terms?
So
Becca?
we're always starting, if they don't give us a number to start with, we're always just starting at 1 and going.
Oh, yeah.
Usually.
Yeah, right. If they don't give us a different starting number, yeah, if they just list, yeah, good question. When they just list it with an in formula, it's always starting at 1. Yeah, the only way they could change that is if they actually gave you sigma notation and the thing down here was some number like 2 or 3 or 7 or other than 1. But yeah, if they just list a formula, yeah, Becca's question is a good one. She was saying if they just give you a formula, does it always start at 1? It does. They want you to start at 1. That's correct. That's just how they do it in the field. Okay, so we got our first 4 terms, 15, 16, 17, 18. Now, the difference means what's the jump from term to term? Well, it's just going up by 1 every time, isn't it? The D is just 1. Remember, there's always going to be the same, in this section, this is the arithmetic sequence section, you're always going to add or maybe subtract the same number every time. Common difference, it's called, because you're adding or subtracting the same number every time. The terms are different from one another by the same difference, common difference. Spaced out evenly. All right, want to try number 2 there? Same kind of thing. Number 2 is giving you a new formula, 6n minus 8. Wants you to find the first term, second term, third term, and then find the common difference.
D equals 6.
So 6n minus 8. So so the first term is going to be 6 times 1 minus 8, which is negative 2. The second term, 6 times 2 minus 8, what's that, 12 minus 8, 4?
10, 16.
6 times 3 minus 8, 10. Yeah, they want a fourth term. 6 times 4 minus 8, 16. Is that good so far? So I'm just taking that formula they gave, 6n minus 8, and I'm just plugging in 1, plugging in 2, plugging in 3, plugging in 4, cranking out the numbers. And now, how much is it? What is the difference from term to term? What's it going up by every time? Yeah, it's adding 6, isn't it? Every time. So the common difference is 6, and there's the first 4 terms, which is what they want. So again, it's an arithmetic sequence, meaning arithmetic, adding, subtracting. It's adding the same number every time from term to term. The jump, you could call it the gap. The jump from term to term, same every time. It always will be in this section. Hey, is there a way, math, science, it's all about patterns, right, like we're talking about. Is there a way we could apply that right now? Is there a way, just by looking at that formula or this formula, without doing any work, you could immediately know the difference, what the difference, the jump, the D, is going to be right from the formula, without finding actual numbers?
6 at beginning number?
Yeah, it's the number, the beginning. What do you mean by beginning number?
In front of it?
In front of n. It's the number in front of n, huh? It's the number in front of n, isn't it? Because here's 6 in front of n, and the difference was 6, huh? And here was, what was in front of this n? Nothing, which means 1, and sure enough, the difference was 1, wasn't it? We good with that? So just a nice little observation. That'll speed up our work. So whatever the number in front of n in the formula, that's the difference. That's what makes the jump happen from term to term. Because as you plug in 1, 2, 3, you're multiplying that by 6. The negative 8 isn't changing. It's just how many 6s you're going to have. 1 times 6, or 2 times 6, or 3 times 6. So that's going to increase your gap by 6 every time. See that? See how it's the number multiplied by n? All right. Do better work for you guys. So let's just do the D. What's the D? What's the common difference? Negative 2. It's the number multiplied by n, right? The rest, you can crank them out. I'm going to move on. Okay. So, and what do they want? They want the 72nd term. Okay. So, can we find some of these terms? Let's just start by finding some of the terms. What's going to be the first term?
1.
Well, yeah, they're just telling me directly, huh? It's 1. The first term is 1. What's going to be the second term?
The difference is 4, so it's going to be 5.
Right. So they're adding 4 every time, so it's going to be 5. So, all right, D is the difference, the jump from term to term. The number you're adding or subtracting every time from term to term. So can we find the third term? Yeah, just add 4 again. 9. Can we find the fourth term?
13.
Okay. Keep going. Which one do they want?
No.
Yeah, right. We don't.
Plug it into a formula.
Right, we want a Gauss type observation. We don't want to add the numbers 1 to 100 on our little slate. We want to use the logic that is in our brain. Train the use of that better and better. How could we get all the way out to the 72nd term?
Add 1 to 72, right?
It's going
Could
to
we
be
do that? Could we do what Gauss did? Could we add the 2?
Well, remember, we're not adding these up. They're not saying add up all. We'll get to that. See, I kind of jumped to the end of the section. Right now, we're just finding the individual numbers. We're not adding them all up. That's what we do at the end, where we add them all up. We'll get to that. That's what Gauss was doing, was adding them all up. We're just listing them. We're just wanting to find them.
okay.
So we're not adding them to each other.
So
Now, we are adding a 4 every time to get the next one. Yeah.
So
2 times 4, and then just add the 1.
Yeah, how about 72 times 4? Just add the 1. What makes you take 72 times 4?
Because you're just adding 4 each time.
Yeah. So there's 72 fours. Yeah, you're just adding 4 every time. Right? Does that make sense? Does that make sense what he's saying there? Right? Austin, right? Austin. What Austin's saying, he's saying, look, you're just adding 4 every time. You have 72 terms. So you're adding 4 72 times. Plus you started at 1, right? You start at 1, add 4, add 4, add 4, add 4. That's why he's got the 1.
4 and plus 1
And add a bunch of 72s.
would be 4.
So is that right, first off?
would we add 72 instead of 1?
72 instead of 71? Or
No, sorry. 72 instead of 1.
well, we started at 1.
We started at 1, so we have to add. Okay.
Here, let's do this. Let me. You guys are right on track. Let me help you make the observation really carefully. Here's how you want to work in like math and science when you're trying to make an observation of a pattern in a formula. Let me show you. What we've done is pretty good, but it needs a little more careful observation. So Austin's observation is a very good one, but it needs a little fine-tuning. Let's look really closely. Let's look really closely at the second term. How did we get the second term?
We added 4 to
1 and add 4, huh? Okay, how did we get the third term? Now, I know we just added 5 to less, but let's go from the beginning. I mean, from the beginning, what do you got to do?
1 plus
9.
Austin, you've already seen it, huh?
Yeah.
Yeah. What's it got to be?
About 71.
Right, exactly, good. All right, so how do we get the 13? Start the 1 and add 4 3 times, huh? Isn't that what we did? All right. Right, you guys with me so far? I'm just observing where they came from. Right? We started at 1 and we go add 4, add 4, add 4 3 times to get to the 13. Huh? Okay, so now let's look let's observe. You know, it is all about careful observation. The fourth term has how many 4s?
3.
The third term has how many 4s?
2. And minus 1.
The second term has how many 4s? So the 72nd term will have 71 4s. I could write it like the other ones. It would be 1 plus 71 4s, wouldn't it? Does everybody see that? Right? Comparing the term number to the number of 4s, it's n minus 1. It's 1 less, isn't it?
Oh, 1 plus n minus 1.
We'll get there.
Okay. Put the formula.
Want to be there, huh? Does everybody see that observation I'm making? Right? See how it's pretty obvious when you write it out that way? It's just about careful recording and observing about the pattern. Right? Whatever the term number, you have 1 less 4 than that term number.
I'm looking at that. Okay.
Third term, 2 4s. Fourth term, 3 4s. So 72nd term, 71 4s. Okay, yeah, now let's try to generalize. Yeah, of course, we could get the answer. What is it? 285?
Yeah.
Anyway, but now, yeah, I'd like to generally come up with a formula. How could we find the nth term? Because they're asking us for it. The nth term.
You Google it.
That's the answer to everything.
Yeah.
You just Google it.
Uh-huh.
So, actually, I just really like that. Yeah, I do. I think it's great. I'm sure you do too. You know, we'll be having this. I remember when we first used it, and we're driving somewhere. It was like 4 or 5 years ago, and the girls were talking about that. I'm going to say it wrong probably. One way, one direction. I said it wrong again. One Direction. Is that the big? See, I know you probably think it's crazy. I don't know their name.
No,
One Direction. Is that
Boy
them?
band or something like that.
Right? Okay, One Direction. I always say one way. The kids laugh at me. Anyway, One Direction, and you know they were saying what a great group that is, and da 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 da. They're the biggest ever. And I said, my wife and I were like, girls, I think the Beatles probably have more records than that.
Oh, yeah.
And the girls like, really? I don't know. And then Lizzie got in her phone. About 30 seconds later, yep, the Beatles have more. I just like that truth is that you can grab a hold of truth whenever you want it. Mm-hmm. All right. So anyway, nth term. So what's the pattern we have seen here? So we want to generalize now. We want to say not just this specific numbers, but how can you do it in general? So start with the 1. Now you're not always going to start with 1 though, huh? So what's the name for the first term in general? Not 1, but a sub 1. So just call that a sub 1. It's whatever the first term is, plus, and then 71, what did that come from? Yeah, that's n minus 1. Right, 1 less than your term number, right? If you're fourth term, you got 3 n's. And then the 4, what's the 4? It's not always going to be 4. What is the 4? Yeah, up there it's the D. There's the formula that Renee just found from Google.
Yeah.
Google knows all about it. So an
equals a to 1.
yeah, so we'll call this nth term, we call that a sub n. So let me write it out for you now.
A sub n.
A sub n is a1 plus n minus 1 d. There's the formula we're going to use again and again and again and again in the next hour. Oh, we have less than an hour. My goodness, time's going fast. So there's our main formula. I'm going to put that one up on the board too. We'll just use that one a ton. A sub n is a sub 1 plus n minus 1d. So it's kind of the golden ticket. It's the one we're going to use a lot. So see how we got it by the pattern? Just observing the pattern. The power of patterns. Okay. So, and in fact, in this very problem, I believe they want a sub n formula, don't they? Yep, they want a sub n. So they don't just want the 285 number. They do want that. We gave it to them. Let's also give them now what else they want. They want the a sub n formula. So what do they mean? So they want you to go a sub n equals a1. What's a1? Well, that's 1. Plus n minus 1d. What's d? 4. And then they want you just to clean that up a little bit. So distribute and gather like terms. So 1 plus 4n minus 4. 1 minus 4, negative 3, plus 4n. There's what they want. That is the a sub n formula, meaning with that formula, you can jump anywhere you want. You know, it's like the difference between the old cassettes. Remember, did you ever use the old cassettes? And the new, some of you younger folks maybe have never seen those old things, or I'm sure you've seen them, but never used them. Compared to a CD, right? If you were listening to something on a cassette and something you liked was far down, your favorite song, your favorite sermon, whatever you're into listening to, you'd have to fast forward through all the other stuff to get there, right? But now with the CDs, you just jump there, right? It's much nicer. Well, that's what this formula is like. With this formula, it's like a CD. We can jump anywhere we want. You know, before, we could just add 4, add 4, add 4. So I want to get out to the 100th term. It'd take me a long time. But if I want to get to the 100th term now, plug in 100. Boom. It's 400 minus 3. 397. There it is. I got the 100th term. That quick. You just plug in wherever you want to jump to. So that's what the a sub n formula does for you. You can jump to any term you want. Good? That's what they're going to ask of us. Questions on that? Try that one. A1 is 4. D is negative 9. So find the a sub n formula. So use the formula we now have. Just use it. I'll write it up on the screen here for you. So we're going to use a sub n is a1 plus n minus 1d. So use that, plug in what they're giving you. A1 is 4, D is negative 9. Plug those in. Clean it up. Get the a sub n formula. And when you got it, then you can do the second part easily. Jump to the 64th term. So A1.
Isn't this a little bit backwards?
I don't think so.
No,
Backwards in what sense?
Shouldn't it be negative 9 times n minus 1 plus 4?
Well, that's fine. Yeah, that's the same thing. So we get 4 plus negative 9 n plus
What was it, 64?
9.
The what term? The 64th term?
Yep. So that's 13 minus 9n. We all good there? Thirteen minus 9n. Now a sub. Becca, question?
Oh, sorry. If it can be reduced, should you do that?
Yeah.
That can't. But
Yeah. Oh, the one you're doing can. Yeah, sure. So now they want us to find the 64th term. So now we just take that formula and plug in n as 64, huh? You tracking with me?
Mm-hmm.
This is in, isn't it? The subscript, the low down numbers you're in. So it'd be 13 minus 9 times 64. What's that, 540 and 36? 576? So that minus 5, 6, 3. My pen is not doing.
563? Yeah, that's what I got.
Minus 563. There we go. Good enough? I'll move ahead. If you're good with that. Okay, so they're giving me the 9th term and the 19th term. And they're gonna ask me for, basically they want the formula. Want me to find A1, D, they're gonna ask for everything under the sun. They want the formula, they want recursive pieces, they want the A1, the D, the whole A sub n formula, then they want the recursive version. They want everything. So how can we, what's interesting, they're just telling me 2 specific terms, huh? The 9th term and the 19th term. And from that, and the fact that it's an arithmetic sequence, right? It's adding the same number or subtracting the same number every time. From that information, how can I figure out the formula?
Yay! There we go.
So let's start. So let me draw this out for you so we can think about it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9th term is 18. I don't know what the first 8 terms are. 10, 11, 12, 13, 14, 15, 16, 17, 18.
I'm never doing that.
19th term is 48.
Yeah, this one.
So they're telling me the 9th term, and they're telling me the 19th term. And just from that, somehow, let's start with the D. Could you figure out the difference, the jump?
3.
Whoa, that was quick. How'd you figure that out, Abdul? So whatever the D is, it's the jump every time. What'd you do? These are all D, huh?
So I did like that, and 9 is 18, so I added like 30 is 48.
So yeah, you went from there to there, and you observed. How far is it from 18 to 48?
30.
30, if you subtract them, right?
Okay.
So that went up by 30. Let me just write it out there. It went up by 30, didn't it?
Mm-hmm.
From 13 to 48 goes up by 30. Positive 30. How many jumps to accomplish it, to go from here to here, is to go up by 30? How many jumps, equal jumps, made us go up by 30? Yeah, because you go from the 9th term to the 19th term. That's 10 jumps. So 10 jumps to make you go up by 30. Just divide this by 10. Each jump must be going up by 3. Huh? Does that make sense? So that's our D. That's our D. That's the difference from term to term. So you just take the total. It went from 18 to 48, which is a total of 30. And it did it in 10 jumps. 9th spot to the 19th spot. So total of 30 divided by 10 jumps is 3 per jump. So the D is 3. So we got our hands on D. Now that we've got D, we can use the formula to get everything else. This plan making sense? So step one is to get D, which we've got. We've got D. Okay, step 2. Now I'm going to use the formula. What formula? The main one, which is A sub n, so one we're going to use all the time, is A1 plus n minus 1d. I now know d. And then you can just plug in. Now, this is where I want to help you. This is where there gets to be like a lot of numbers. It's kind of confusing which to plug in. The ordinal numbers, let me write that. Do you know what an ordinal is? An ordinal implies ordering. So it'd be a number like 9th or 3rd or 27th. You know, numbers that imply an order. As opposed to a regular, oh, my pen, I got to fix this thing. A regular number is like, 3 or 5 or 9 or, it doesn't have a th at the back, right? So if I say 3, that's just 3. But if I say third, that implies, there's a first, a second, and a third. It implies ordering, right? We call those ordinal numbers, imply an ordering. So the ordinal numbers are always your n. That's how you know what that is. The ordinal numbers are always your n. So when it says 9th, you go, oh, the 9 is the n. So that means I can plug this in and go a sub 9. I'm going to put a 9 in for n everywhere. Is a sub 1 plus 9. See how he became 9 and he became 9? And d, what's d?
3.
D is 3. So then, and they're pretty good so far. So I just took our formula, the one we're going to use all the time. A sub n equals a1 plus n minus 1d. Plugged in 9 for 9th term. Plugged in 9 for n. The ordinals are in. Plugged in 9. Now, what is a sub 9? What is the 9th term?
18.
18, they told me. So 18 is a1 plus, and this is 8 times 3. 24. 24. Last step to solve for A1.
18 minus 14.
Subtract the 24. So minus 6. A1 is minus 6. So I've got A1. I've got D. Now I've really got the formula. I can go over here and erase this stuff. I've got the formula. That's what they want. They want me to give them the formula. So I can do it now. So, okay, so now the formula is A sub n. Just keep using the same thing. A1 plus n minus 1d. A sub n is A1, negative 6. Plus n minus 1d. D is still 3. Distribute that, clean it up a little bit. A sub n is minus 6 plus 3n minus 3. A sub n is minus 9 plus 3n. So, that's almost everything they want. Let's go back to their questions and I'll show you. So we took those two pieces of it. There's a lot to these problems. So, they're asking for the first term. That's a sub 1, which we now know, negative 6. They want the common difference, the d, which we found out is 3. Now, here's something different they want. They want the recursive formula, starting with a1. So they want a1 again, same thing it was a second ago, negative 6. Just write that again. And then you see the second part of the recursive? They say the nth term is the n minus 1, which means what? Previous. Remember, that's one back, isn't it? N minus 1 is one back. So that means any term is the previous term plus what? You tell me. As you look at this sequence of numbers, any term in this list is the previous term plus what?
3.
3, yeah. It's the d. They basically want the difference from term to term. That's what you're adding from a previous term to the next term. You're adding the d. You're adding the 3 every time. Does that make sense? That is the d. What you put here is 3. That's the d. That's what a recursive formula means. Any term is the previous term plus whatever the difference from term to term is. Okay. Lastly, a sub n. What's the formula phrase? And we got that, right? That was right here. Minus 9 plus 3n. Minus 9 plus 3n. And we're done. Is that good? Are we okay on all that? Those are long. I can't really do many more of those. We good? Here, let me rewrite 16. They're basically saying the 12th term is negative 6. And the 18th term is negative 24. Okay, so step 1, find D. So find the difference the way we did. Give you a second. So from here to there, it went from negative 6 to negative 24. How far is that?
18.
Is that going up 18 or down 18? If your bank account goes from negative 6, ever had that happen? I have. From negative 6 to negative 24. What's going on with your bank account? It went down 18, huh? And how many jumps did it take for that to happen? 6 jumps. From the 12th spot to the 18th spot, huh? So divide by 6. That's negative 3 per jump, which is D. D's the amount per jump, huh? Good, we got our D. That's step 1. Step 2, you've got to find, I'll bring it over here. Step 2, find A sub 1. So A sub 1 and D are the two B's. How do we do it? We use the formula. The main formula we've been using, which is A sub n is A1 plus n minus 1d. Can you use that formula to find A sub 1?
Don't we have to know A sub 1?
Well, what we can do is, remember, we just plug in the original information. So the 12th, what is that? It's an ordinal. So what is it?
A sub n.
N. That's in. So the ordinal numbers are in. Is everybody tracking with me on that? I'll write that. Ordinal numbers are in. The ordinal, like the TH kind of numbers. You know, the 12th, 18th. Those, the TH numbers, the ordinal, the numbers that imply ordering, those are always your N. So the 12 and the 18, those are both N values. I'm going to just do the 12. So plug in the 12 for N. And you'll have A sub 12 is A1 plus 12 minus 1D. And what's D?
-3.
D is negative 3, I already found.
Wait. It'd be 11. -3.
And what is A sub 12?
6. -6.
Yeah, this is the 12th term. Right? The 12th term is negative 6.
-6 in for that?
Yeah, this whole thing is negative 6. The 12th term is negative 6, exactly. And that's what, 11, negative 33?
33. Oh, yeah.
Am I going too fast? Is that good? See what I'm doing there?
-30.
On this second step. So I'm just using the main formula that we use a lot. A sub n is A1 plus n minus 1d.
Oh, wait. That's plus a negative. So it's going to be A sub
So I plugged in the n is 12 everywhere.
plus 33.
And now we can solve for A1. A1's 27. So now we have A1 and D. Now step 3. We can write the formula. Again, to the A sub n is A1 plus n minus 1d. We just keep using that formula again and again and again, don't we? A sub n is A1 plus n minus 1d. But now I know A1 and D. A1, 27, D, no, not 27, negative 3. And then that negative 3 distributes.
27 minus 3n plus 3. 30.
30 minus 3n for the a sub n formula. And then you just do the recursive thing, which is the same as it was last time. I'm going to move on if you're okay. Questions on that one? It's the same thing. I just wanted to run over one more of those. Those are important and kind of long. Does everybody see how we find the d in the beginning? Start by finding the d. And then we use the a sub n formula to find a1. And then we plug it all into the a sub n formula. All right. Okay, yeah, so we want to add those up. Now notice things have shifted. I don't know, it can all start to kind of look the same. I always know when I'm starting to get the hang of material is when it stops all looking the same. And I start noticing the differences. All right, notice there's plus signs now. All of a sudden, we're adding them up. We're not just listing them now. Now we're doing Gauss's thing. Now we're adding them all up, aren't we? So let's go to the Gauss. Let me remember what I did in the beginning of class when we were adding up all the numbers 1 to 100, or Gauss was, right? And we saw the pattern. He added the first number to the last, got 101, and then just kept doing that. Whoop, not 100. And then, all these are 101, and then he said, okay, there's 50 101s, and got his answer. So let's generalize that. We want to come up with a formula using that idea that we can make work for us at all times. So the first term is not always going to be 1. It'll be a sub 1. Could be any first term. And the last term is not always going to be 100. It's going to be a sub n. That's what we call the last term, a sub n. So then, instead of these adding up to be 101 every time, what's the first one plus the last one going to be? If it's a1 and an, well, it's a1 plus an. That's all we can say. In general, it's first term plus last term, right? All these are the same, though. Remember, whatever the sum is, it's the same for all of them. That's what Gauss observed. Was a great observation. So it's same for all of them. Okay. How many, so instead of 101 here, it's a1 plus an, isn't it? You with me? Now, how many 101s? Gauss said there were 50 101s. How did he come up with that? You guys came up with it too. Yeah. Yeah, it's half of the 100, right? Because you say, well, there's 100 terms. They're breaking into groups of 2, right? They're making a little rainbow, rainbow, rainbow. How many of those rainbows they're going to be 50? Because there's 100 terms, and they each, 2 at a time. It's going to be 50 little rainbows. So 50 101s. So how many a1 plus an's are there? Well, we don't know how many terms there are here. Let me just tell you. There's n terms. Remember, we're wanting to be general. Let's just say n. There are n terms. So it's, so it's half a n, or 0.5 n, isn't it? That's the number of those there are. It's however many terms you have, cut it in half, just like 100 cut in half was 50, huh? Because you're breaking them in groups of 2. Does that make sense? That's our formula. That's what we're going to use. And we'll call it S sub n. What does that S stand for? Sum. Adding up in terms.
10? SN? 10?
So
You get it?
we have to figure out.
No chemistry here, please. Periodic chart. Yeah. What's that?
I said so we have to figure out how many terms there are.
Right. And that will be kind of a lot of work.
Yeah.
That'll be the hard part. You're right on, Becca. That's the sticking point. So this makes sense? This is the general form. This is what Gauss did. He said however many terms divided by 2, like 100 over 2, 50 terms, times first plus last. Because they're all going to be the same. The rainbows, right? All right. But yeah, Becca's right. That formula is not going to be as easy as we think. Let's get back here. So as soon as we see, now how are you going to remember all this on the test? Well, you're going to write the A sub n and the S sub n. Let me write them both down on your 3x5 card. A1 plus n minus 1d. And S sub n is n over 2 A1 plus AN. So those are the two most important formulas in this section for sure. And we're going to have in the next section, geometric sequences Tuesday. Then we'll have the same two. We'll just kind of up them a level. In fact, if you could go through there and take every operation and raise it up a level, you'll have the other formula. What do I mean? Adding becomes multiplying, subtraction becomes divide, multiply becomes powers, raise everybody up a level, and you got the new formulas. Anyway, so A sub n, S sub n. What's the difference? A sub n is for finding terms. S sub n is for adding them up. S is sum. So that's how you'll know which one to use on different problems. If they're adding them up, so you see this question, you go, oh, they're adding them up. I'm going to have to use which formula? Yeah, the S sub n.
This is the last step that we covered in 103 a year ago.
Oh, did we?
Yeah, this was the last step. This was the last thing
that's
that you
right.
added onto the final exam.
I'm impressed that you remember some of that.
I remember everything.
All right. I wish I remembered a little bit more.
Except when it comes to test time.
Yeah.
And I don't remember it.
All right, so we're going to use that formula. Now, let me help you, though, with that formula. It's important to know what the different players in the game are and not just see them as letters. So n is remember it was the number of terms back over here. Remember in terms is the number of terms. So, and A1, what's A1? What was A1? The first term, and AN was the last term, huh? So let me write that down for you just to be super clear on that. So n is the number of terms, which we don't know, like Becca said. We don't know. So let me just leave that in for the moment. But we do know the first term and the last term. 8 and 68. We good so far? So we're almost ready to finish this problem, able to add these all up, but we don't know how many terms are there. Now this one's easy enough, you might be able to figure it out different ways, but I'll just give you a way that'll always work, a formula. So what we could always do to find n is go off to the side and use the other formula, the A sub n. So this problem's fairly challenging in the fact that we've got to use both formulas. To find n, we have to use the other formula on the side. The main one is still the S sub n. That's the one that's going to give us our final answer. But to complete it, to get the n piece, we have to go off to the side and use the A sub n formula. We'll find n over there, bring it back, plug it in the S sub n, and finish up our answer. That's the plan. Okay, so how are we going to do that exactly? Well, I'm going to plug in what I know about this stuff. So what's A sub n first off? Notice it's right there. A sub n is 68. Means last term, doesn't it? 68. What's A sub 1? First term. 8. Huh. We good? Remember, A sub n is last term. A sub 1 is first term. Plus, n's what I'm looking for. What's D?
2.
Yeah, what's the jump from term to term? It's adding 2 every time. Solve that little equation for n. Bring it back, put it in the S sub n, and get your answer. So let's distribute. 8 plus 2n minus 2. 8 minus 2 is 6. Finish solving. Subtract 6. Subtract 6. Boom. 62, 2n. Divide by 2. 31 is n. N is 31. So there's 31 terms up there. 31 terms. So take that now and bring it back. So I'm going to grab that 31, and I'm going to bring it on back and put it in right there. And that'll become 31. So my S sub n will be 31 over 2. Add that up. What's that? 76. So hit the buttons on your calculator. Somebody got an answer?
1178.
1178? Thank you, Naz. 1178. 1,178. So we just added up all those numbers without doing it one by one, using the formula. How are we doing? We good? All right, shall we try? Let me see. We got 12. Find the sum. Add those up. So start with the S sub n formula. Start with that, but you're going to need to use the A sub n on the side. So there's the S sub n. We know. How do we know right away we're going to use the S sub n formula? Well, because they're being added, huh? So when you see sum, when you see them being added, you know you're going to start with the S sub n. But yeah, then we're going to, because of the n, we're going to use the A sub n on the side also. That's right. So remember, this means number of terms, first term, last term. Number of terms, first term, last term. Good, so to find that in, go off to the side, use the other formula. And so that means, remember again, A1 is the first term, A sub n is the last term. So 92.5 is the first term, 3 plus n minus 1 times the last, the D. And what's the difference? What's the D?
1/2.
Yeah, it's going up by 0.5 every time, isn't it? It's adding 0.5. So that's the D. And then distribute that. These are long. You guys making it through the sea of algebra here? So I'm getting 180. There's 180 terms? Did you get to that? There must be 180 terms up there. So now bring that back.
180 divided by 2 is 90.
and then finish her up. So I'm thinking 8,000 something, maybe 9,000. Oh, I'm just guessing. I should do my. Is that what it is? 1125?
I got 8,595.
Uh-oh, that's closer to my original thought.
I added 9.5 instead of 92.5.
Ah,
I have too much.
8595. Yeah. Is that making sense? How to add those numbers all up?
Oh, I got 3.
You good? I want to do a couple more with you as time allows. We okay? All right, I'm going to move on. Works. You start here, and you end here. So you plug in 1, plug in 2, plug in 3, all the way to 120, huh? And then S, that's a Greek S, sum them. So plug in 1 to the formula. What do you get? 6 minus 1/3 times 1. Plug in 2 to the formula. What do you get? 6 minus 1/3 times 2. Plug in 3, plug in 4, da-da-da. So now what is 6 minus 1/3 times 1? Well, 6 minus 1/3.
Yeah,
17 over 3.
Yeah, right. So just to subtract those, put this one over 1, common denominator. This one's a little painful. 18/3 minus 1/3, and that's good fraction work. 17/3, or 5 2/3, like Becca's saying. Right? You can always go 6, take away 1/3 is 5 2/3, right? You have 6 pies, you lose 1/3, you got 5 2/3. Okay, so that's the first term. Let's find the second term. Second term is 6 minus. Now, what does that whole number 2 do when it multiplies to 1/3? It's 2 over 1. Any whole number's over 1, so it's 2/3, huh? So this is 6 over 1 minus 2/3.
Okay, 6 and 3 cancel.
So, oh no, we're not multiplying.
Oh, it's subtraction. Okay.
Multiply top and bottom by 3. Get 18/3
20/3.
minus 2/3 is
Oh,
16/3. That's the second term.
6 times 3 is 18 minus
So is
2.
it going back?
6 times 3 is 18.
Yeah, remember what we learned? The number multiplying the n is the difference. We should have known that. It's going down by 1/3 every time. Of course it is. Remember that earlier observation? So we good? So these are now we're gonna add these up all the way to whatever the last term. Let's find the last term. Can we find the last one? So this was n equals 1. This was n equals 2. What's the last term?
120.
The 120th term, right? It ends at 120. So plug in, so 6 minus 1/3 times 120. That's over 1, so that's 120 over 3. That's 40, no fractions needed. That's minus 34. The last term's negative 34. Are we good so far? Now we're ready for the S sub n. What's the S? Because we got to find the sum, right? So the Greek S leads to the English S. Sum with sum, right? So S sub n is what? According to Gauss's observation, n over 2, a1 plus an. All right. Now, normally, this is where this one will be easier than the last one. Normally, to get n, what is n again? What does it mean? Number of terms. And a1 is what? First term. And an is what? Last term. Yeah, so normally to get n, the number of terms, we'd have to go on the side and use the a sub n formula. But this time we know how many terms. How many terms?
120.
120. That's what's so nice about the sigma notation. It tells you where it ends. 120 ends clearly 120. There's 120 terms. No guessing about it. Is that good? 120 over 2 there?
So that's not the number. It's n sub 120, not. I'm sorry. I was thinking if that's where it ends, like 120 more, but it's not. It's
So
negative 34.
right, yeah.
Yeah.
So those are the numbers you plug into the formula. You plug in 1, plug in 2, plug. Yeah, right here. Plug in 1, 2, 3, all the way to 120, and the last one is negative 34. Yeah. So it's 120 terms. First term is 17/3. Last term is negative 34. And so we got to work that out. Oh, they're letting you type in a decimal. Yeah, so just do it on your calculator and you get a decimal. Oh, it'll come out a whole number, actually. It'll be a whole number. Yeah. 1 minute. Do we have 1 minute? Let me show you the word problem. Well, no, we don't really have a minute. You're going to have to go on YouTube for that, for those word problems. There's like 4 or 5 at the end. We did one of them. We did that triangles one, right? So the other ones are, there's a Drury Lane Theater one and a couple other ones. Word problems. Use YouTube for that. This is as far as we could get.